Hello everyone, I'm a PhD student of Solid Material and Smart Design Laboratory. Today I feel very proud when to be here for sharing my research topic, that is single-seagrass screen under a sinusoidal velocity by fluid structure interaction simulation. For the first presentation, I will talk about main goals of this study for all of you easy to follow. In this study, I aim to validate the single-seagrass bending undergo to flow by an experiment and simulation. And the simulation is the first step of this study, that is the work I talk about today. An independent test for the domain length is conducted to find the suitable length for simulation. After that, a represent simulation is conducted to find the behavior of single-seagrass under water flow, especially the water flow in this study in form of sinusoidal signal. Before simulation, the material of seagrass have to be defined. Because of the difficulty for using the natural seagrass for study, then we tend to use the artificial seagrass. Here the table shows some study in literature use artificial seagrass. There are ribbon, polypropylene, bamboo dowel, wooden dowel, plastic plant, and PVC. In this study, we choose the polystyrene for making artificial seagrass. And here is the table shows some density, young modulus, and Poisson ratio of polystyrene. And here is some example of application of polystyrene in the real life. In this study, we apply the fluid structure interaction FSI simulation for modeling the bending of seagrass under water flow. This method can define by the interaction of some movable or deformable structure with an internal or surrounding fluid flow. And here shows the example of FSI method, where the seagrass species is bending and flow field change due to this bending. The FSI method can classify into two types, one-way and two-way FSI. Like their name, the one-way FSI is only consider the effect of fluid on the structure, then structure deform, but its deform is not effect on the flow field. Different from the one-way FSI, the two-way FSI is not only consider the effect of the fluid on structure, but also consider the deformation of structure on flow field. And if we have to choose a method for fully modeling the behavior of seagrass deformation on flow field, the two-way FSI is the better one, because two-way FSI consider the effect of structure on flow field. For that reason, we apply the two-way FSI in this study. The volume of experiment has the dimension like the figure. There is 0.5 meter of width and height, and the length is up to 10 meter. Because of the volume length is too long compared to the width and the height, then we did the independent test to define the suitable length of this study. The independent test, that is the procedure when we randomly choose the domain length, were 0.5 meter, 1 meter, 1.5 meter, 2 meter, 3 meter, or 5 or 10 meter for modeling. And we consider the deformation of seagrass change so that where the deformation is convergency, that is a suitable domain length. And we see the domain length from the length is 3 meter. is conversion, and so there is a suitable domain land of simulation. Here shows the boundary condition of the domain. The front surface is assigned by the inlet boundary condition, where we can define flow, velocity, magnitude, turbulency model, etc. The back surface is defined by outlet, where we can define environment pressure. The top surface and two side surface are defined by symmetry, where the left side and right side of symmetry boundary condition is similarly, and the last one is bottom surface is defined by Gauss boundary condition, where is stationary Gauss, no slip Gauss, and we can define roughness model. This figure shows the mat configuration. As we see, the mat type is tetrahedrons, and the maximum mat size is 15 mm. As we see, the mat size reduced around the structure, and the smaller mat size is located around the seagrass or structure, and the larger mat size distributed in another area of the domain. We also consider the quality of mass. As we see, the mass quality is very good, no matter we check by skewness or orthogonal method. Here is independent test of some simulation parameter. The domain length we already explained in the previous slide, and at here we saw the independent test of number of steps, analysis time, and number of elements. Finally, the simulation parameter of the study were defined and shown in the table, where the domain width and domain height are the actual size of volume experiment, and the domain length and number of steps, analysis time, and mass size are the resultant of the independent test. In this study, the rate of flow is defined by a sinusoidal velocity, which is in form of the equation, where V is the rate of velocity, A is amplitude, omega is angular frequency, T is time, and V is phase. For the first investigation, we simplify the rate of velocity as the equation, and the figure shows the amplitude of rate of flow, where A is amplitude and 2 pi over V is wavelength of the wave velocity. Here is the cigarette deformation flow in time, and as we see, the bending magnitude or bending decrease change each time. This deformation is unpredictable. According to the change of the magnitude, the projection of cigarette changes, and a lot of studies to that the projection of cigarette is the main parameter to quantify the wave attenuation, the drop coefficient, or damping coefficient of cigarettes. Therefore, define the exactly cigarette height under rate flow is more important. The fluid structure interaction abated simulation can perform well the behavior of structure and their surrounding fluid flow. This method not only estimates the bending or force of structure, but also perform the fluid flow change around this structure and effect of it back to structure. This simulation is the first approach, hence the similar experiment is needed for validation. Thanks for your attention.